All right, so I am going to be demoing today a new thing that we're able to do in the RPM plugin. But first, I'm going to give a brief background on why we have this. So in the RPM plugin, we have a need in various places to sort packages by Nevra and by EVR. EVR is epoch version and release. It's kind of the RPM versioning scheme, and it's not quite a standard versioning scheme in the Semver sense. It's extended, so it's not just Semver. It's also got some special operators, and they have special meanings in different positions. And so you especially cannot just compare the strings like for like. But you also can't use normal version sort routines on them, like some of the ones you can find. And a lot of the ones you can find on the internet are also wrong. And we also, because it's the RPM plugin, because we're dealing with a lot of packages and in important ways, we also need it to be somewhat fast. So one of the places where we do this is when we make a publication, you want to have all of the packages in sorted order for two main reasons. One is compression. RPM metadata is huge, and if all of the like packages are next to each other, then it sorts extremely well. Then it compresses extremely well, and if they're not next to each other, then it compresses extremely badly. And for the sake of our users and their disk consumption, we want the metadata to be sorted so that it compresses well. And we also want it to be sorted so that if you were to make the same publication multiple times, it would share the same files and artifact storage. Because if they're the exact same, then it can just reuse artifacts. Whereas if it's even slightly different, if the order or anything about the files is even slightly different, then you have to save entirely new artifacts. And we also use it in retain package versions. So if you have, if you want to set a limit on the number of versions for each package to keep in a repository, then you need to sort the top N versions, and that also needs to be done quickly. And it's ideal if we can do it in the database. In both of those cases, it's ideal if we can do it in the database. And historically, we had this SQL extension, PLPG SQL code. It doesn't matter what it looks like. I don't need to zoom. We don't need to pay too much attention to it. But we've had this extension, and it was wrong. It did not give the correct results. We discovered, and we tried over and over to fix this, and it was extremely difficult because the RPM version sorting routine is somewhat complicated, like I said, and it's the different operators are kind of context dependent. It's very difficult to implement in PLPG SQL, and so for about a year, we had not been using this for at least for the sake of retained package versions because it wasn't correct. And what we discovered is there's a different approach to doing this, and this approach is extremely simple, extremely flexible. And I wanted to call it out because other plugins might be able to make use of this, and because there's some really cool things you can do. So the crux of this is that there's a new way of sorting RPM versions in the database, and that this new way of doing it basically encodes the RPM EVR as a binary array value that can just be sorted using like standard memcomp or memcompare semantics. So like the database's internal default way of sorting a binary array works. It works fine. So that's extremely fast because the database is using its own internal routines that are like the most optimized they could possibly be, basically. And it's indexable, unlike our previous solution, and it's correct. And I'm not going to go into the details of exactly how this works. You can look at exactly how it works. It's in the migration file 0072 fix EVR version sorting. There's a nice description. But it basically encodes it as a binary array value, and that can be sorted. But that's not actually the main thing I wanted to talk about today. The main thing is, with this approach, what I realized is that if you can create these same values from the application code, and you can create these values from the application code, what you can do is do range requests on package versions, and it is correct. It works. So I have synced the rel 9 base West repo, and you can see there's a bunch of different versions of the kernel package. There's 105 of them. And and I've sorted this list by EVR. Otherwise, it would be in random order. And you can see that that version is correct if you were to stare at this for 10 minutes. But if you can create these EVR sort key values from application code, then you can filter packages by EVR ranges. So EVR greater than or equal to this sort key, and EVR greater than or less than or equal to this sort key, order by EVR, and this works. And the boundary conditions also work. So if you say, instead of less than or equal to, it's less than, there's now a new version here, or sorry, there's one less version here because it filtered out the last one, and you can just change this around, and everything works, and it's fast. It's inside the database. It hits the index, and you don't have to do anything from the application code basically, except for generate these values representing the EVRs, which is also fast. And you couldn't do this any other way, because if you just tried to filter by epoch and version and release separately, it doesn't work. It's wrong. And so this provides some interesting options for like features we could provide on the REST API in terms of filtering the output. It also, there's some things that could potentially be sped up by using this, and in general, it's just kind of cool. And also, because you can generate these values from application code, in theory, you don't even need the database extension like the RPM plugin has. If you were a different plugin like Python, for example, you could write a function that produces the same kind of values. It wouldn't be identical, because a Python version is different from an RPM version. It wouldn't be identical, but you could do the same, use the same concepts, and you could save these values alongside the package, and without having any triggers or anything like that, like the RPM plugin has, you could do the same thing. And so that's the demo. And I hope people found it interesting and maybe useful. Any questions? And the code is not that complicated for generating the keys. It's only about 100 lines of code, actually less, 75. Right, no questions? Okay, I will let David get on with it.